Okay, so guys, this is a review of radical and rational functions for your exam. And I've taken some questions from the standards and exemplars. And we're starting off with a numerical response question. So it says the graph y equals square root of x is transformed into this. And the list of possible transformations is shown below. So what I would do is determine what are the transformations that have occurred, find them in this table, and then down here you have to list them. So the transformations from the list above that describe the changes to the graph of y equals root x are, and there are 3 of them, so you need a 3-digit number. So give that a shot and come up with your 3-digit number, and then I'll go through the answer with you. Okay, so what I would do here first is factor out the b value, which is -1/2 times x, and I want to end up with -4 here, so I need to put in +8. And you can see that if I were to distribute this again, I would get -1/2 x minus 1/2 times 8, which would be -1/2 x minus 4. So hopefully you saw that. That's the trick, to remember to factor out b. So b is less than 0. That means a reflection in the y-axis. So we're going to need this. B is 1/2, so that means a horizontal stretch factor of 2. Remember, the factor and b are reciprocals. So that would be this guy. And then lastly, h is -8. Remember, the sign looks different. So that's going to be a horizontal translation of 8 units left. So hopefully you saw that. All right, let's see what we've got next. So here the graph of the function y equals f of x is shown below. Here it is. It's an absolute value function here, and then there's a horizontal line kind of portion there. So what we are asked to do in this one is just to sketch the graph of y equals the root of this function and state the domain and range. So maybe copy that graph and give that a shot. Okay, so things to remember here are that the invariant points we want to start with. And invariant points occur at y equals 0 and y equals 1. Y equals 0, so there where I marked at the origin, and here at -3, and then also at y equals 1. Remember, that's because the square root of 0 is 0, and the square root of 1 is 1. So we have those invariant points there. When I'm drawing the sketch of this, what I want to look for is that between 0 and 1, that the square root function is greater than the original, and then later that it's less. So we have something like this. And because this is a constant value of 2, down here this is a constant value of square root of 2. Whereas on this side, I'm going to have something like that, square root function there. So then lastly, the domain and range. So the domain is that x goes from -infinity to -3. That's right here, this point. And then from 0 to infinity. Oh, and this should be a curved bracket, excuse me. And so should that. And then the range, as with all of these, right, the range includes 0 and then goes up. So hopefully that's what you got for that guy. So here's another numerical response, and this says the graph of the function f of x equals 1/2 x minus 3, and it's transformed into its square root. The invariant points on the graph are located at a comma b and c comma d. So I want those values down here. So take a minute and see if you can find those. All right, so again, the same idea of invariant points occurring at, points occur at y equals 0, which are x-intercepts, and at y equals 1. So all I'm going to do is put those into here, into my function, and see what I get. So 0 is 1/2 x minus 3, add 3, and then I would times this by 2 to cancel out that down there, times this side by 2, and I would get 6. So x is 6 when y is 0. That's my first one. So I've done this, and now I'm going to do for y equals 1. So maybe I'll do that up here. 1 equals 1/2 x minus 3. Add the 3. And again, times by 2, it's the same steps, right? We're doing the same thing. 8 is x. So when x is 8, y was 1. So I'm going to put that in there. And my solution for this would be 6, 0, 8, 1. Or if you found the 8, 1 point first, then you could also have the answer 8, 1, 6, 0. So both of those would be acceptable. All right, here is another one to try out. So give that one a shot. All right. We are looking for the x-intercept for this function. So what I could do is, the question is, what is x when y is 0? So I'm just going to replace, again, this side with 0, make 2, square root x plus 4 plus 3. And I'm going to isolate the radical. Neg 3 is neg 2 root of x plus 4. Divide both sides by neg 2. And then I have 3/2 is the root of x plus 4. And then I would square both sides. So 9 over 4 is x plus 4. And then I would just take away the 4 from both sides. So x is 9/4 minus 4. So that is 2.25 minus 4, which is negative 1.75. And so if we go back to the question, it says the y-intercept is equal to negative k. So that was negative 1.75. So here our value of k is, to the nearest hundredth, 1.75. Just without the minus sign. It's a numeric response. I can't put that minus sign in there. Okay? In this one, you're just asked to sketch some graphs, and there are two choices. Determine the following characteristics for each function. So domain, x and y intercepts, and the equation of the vertical asymptote. So I would say pick this one or this one, your choice, and then try and find that information, okay, just as a practice. All right, what else we got here? Let's see. Here's a good one. If f of x is 1 over x plus 1 plus 3, then the vertical asymptote is located at blank, and the horizontal is located at blank. Oops, excuse me. And here you have to pick the number of the correct oops, the number of the correct equation. So you have to choose one of these numbers for each blank there. So give that one a try. Okay, so remember that the value of k gives me the horizontal asymptote. So y equaling 3 is this one. So that is number 8. And the value of h is going to give me the vertical asymptote. So x cannot be -1. So this is where my vertical asymptote will be. All right. And this one, determine the coordinates of the point of discontinuity of the graph of this function. So give that one a try, see if you can find that. All right, so what we should do here first is factor the numerator, and it is 2x minus 1 and x minus 7 over x minus 7. So I know at this point that x cannot equal 7. And I also know that this will cancel, and I'll get 2x minus 1. So this is our f of x. And x cannot be 7. So there will be a point of discontinuity when x equals 7. So that's half of my coordinates. So I know that it's 7, and now the question is, what's the y value of that coordinate? So I'm going to put 7 into here. So twice 7, so this is the f of 7, is twice 7 minus 1, 14 minus 1 is 13. So there's my point of discontinuity, 7, 13. All right?